Hello, everyone. Good day, everyone, and thank you for joining this. Today, our speaker is not just an engineer, he is the strategic mind behind some of Pakistan's most advanced RF and microwave systems. So here he worked in many organizations and now he is working as the manager in Pakistan. So Hassan Bhai. So Hassan Bhai, thank you very much for joining this, and it's we have honor to have you in this session. Let's begin with your story. So my question is just what sparked your interest in RF and microwave engineering? Because and also we don't know about RF. What is that? If you this is the niche many engineers find. Maybe interesting or something like that, please.
Okay. Thank you, Dr. Saab. First of all, I would like to introduce myself. My name is Hassan Mushtaq. As Dr. Saab introduced and spoke a lot about me, but I have really small story. Growing up, I wanted to be an engineer. Just watch my father go to office and learning about what his profession was. After that, usually I started my school, then going to university. There, we used to have lots of lecture with the teachers and lots of uh, books and all the studies we have to do, but I didn't get why we need a lot of study material to tell everybody, because I was mostly introduced why don't we go to the practical. During my initial university times, we used to like work somewhere, and all the time we have classes of like 3 hours 4 hours that we have break. Then suddenly when our practical classes start, there I used to see a lots of practical things which were not told in the lectures. I still remember, I don't even don't used to know how oscilloscope work. That's a basic equipment that used to my. Then there was I remember there's like fifth or sixth semester of mine where our teacher was from a very reputed university of Pakistan, and he came and told me why you like to come to this lab so often. I told him I didn't get why we have all this lecture and don't have a practical use of it. So he asked me, why don't you make some kind of project this year and tell me how it was. So I remember I selected a project there that's about like automotive, as a little different from my subject that I used to study. There was there in that project we used different kind of sensors, different kind of sensors and different type of equipment. And the thing that clicked in my mind was the how these waves and all the signals used to work. Because always we our teacher told me that signal, this is a sinusoidal wave, this is a square wave. I didn't get how it was possible that somebody is telling me I should accept it. Because we are the kind of people that know that whenever which thing we can't see, we tell them that it is possible. If we see something, we say yes, it is possible. So when for the first time I saw a square, I said it's okay, it is something real. That fascinates me how the things work, and it's not a bookish thing, it's something practical and work on. So that was my first project, that how a car is automatically parked. Because the real reason behind that project was uh, the one of another idea that clicked in my mind, that why we should, as an engineer, we develop the things that practically work in our in our environment. So there was a parking space issue. If you remember, if you're from Islamabad, or any of our viewers from Islamabad, there's a E9 road hole. There's always traffic jam due to the university rush and everything. So one of my teachers asked me, why did you develop such a kind of product? I said, I want, being an engineer, lots of people I saw on internet always come up with some kind of a practical problem and they give a solution to it. So this fascinated me to make this project. And then there was lots of question. I was like really appreciated for that project, and all the different kind of sensors and these things were that fascinate initially for me to work how this engineer profession is helping the environment, our society, change how the problem came, and we have to get this kind of proper solution to the problem.
Was a wonderful, wonderful, Asmai. That's nice. And this is more technical question. You are designed from front end systems up to 40 gigahertz. So, what are the toughest design parameters to optimize at those frequencies?
Dr. Habib, actually, what the field which I'm working in, there's a two types of limit. There's a kind of a low signal equipment, like you have a Bluetooth, you have infrared rays, but where I'm working from is basically purely for the aerospace and industrial. They use a high frequency. Right now, I'm working for 16 gigahertz frequency. That's really hard and really fast to work at. The drawback is the more the power and more hard to handle, and more we have to be uh, more like work on that, so that we cannot get damage our skin, because high wave usually cause really skin damage and lots of other. So we have to be more have create an environment where we have to be protected ourselves and give a practical solution.
Okay, okay, nice. That's nice. And what the collaboration roles with the DSP teams and PCB designers? For,
Basically,
yes.
okay. Dr. B, actually, the system RF design is not a single word, as you can see. It's a combination of different disciplinary studies. Like, for example, it involves signal processing as well. It requires you have a strong electromagnetic theory as well, and then you have to have a strong electronics information as well. So for that, the kind of teams we are working with is like my team. Under my supervision, there is RF technology team that purely works on radio frequency and waveguide. Then there is another team, embedded system, that work on the practical, the coding and all the digital boards. Then there is the power section that like kind of a soul for the whole system, that develops the power system and how the equipment requires the power limitation, voltage and current. And there's the last team that we I say as the bone of the whole team, that's called mechanical team, which kind of idealizes or like put our idea into a box or a practical shape.
Okay,
So
that's
there.
nice. Okay, okay, that's nice. And another question. This is something those who want to pursue this field. Which bachelor is in which field? I mean, this is RF and micro engineering. From which engineering to then master and something like that. What are the directions? Can you please guide to the
Okay.
yes?
Can I call you Doctor Sab if it's okay?
Yeah, 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 sure.
Okay, Dr. Sab, actually, the thing is, when I was graduated in 2012, there was a very limited field. So when I was doing in electrical engineering, but then came like last 2 to 3 semester where we have to do a specialization in specific field. So I did my specialization in electronics, but due to as the RF was a new field to us and very little company, I guess 2 or 3 company was working on that. So I have to gain that experience during my internship and my 6 months time in the office. But now the students that are trying to pursue the RF engineering, they have a specialization after the 4th semester, that they can specialize in RF field. Then after that, when you're doing it practical work or doing some research work, you have to do a master's in that RF field. And then RF has lots of other fields right now. First, there is only radio frequency or wavelength. Now there is the designing involved as well. There's EMIC topics, and you have to like continuously gaining the new degrees or sessions to pursue this field.
And also, Hassan bhai, the master in Pakistani engineering universities are in electrical power, electronics, and then digital techniques and communications. Can I say this RF, this field is linked with communications, or both to communication and digital techniques, something like that?
As I already told you, this is a multidisciplinary kind of
Ah,
a
yes.
field, because you have to have a strong knowledge of electronics as well, which I told you usually students do in their bachelors. Then there is a field related to signals that you can do in masters as well, and some part in bachelors as well. But it's not like a straightforward electronic courses that you have to work with the resistors and component that you see online. Actually, the same thing I encountered when I started working in my professional career. I used to have a simple electronics switch. So there was a project, first project that I was working on it. It was purely radio frequency and microwave. I, being electronics specialization, I tried to pursue and try to run this project on the same ground. But I told you, what we study in the schools or wherever on the online research and articles, that is just limited to words. But when it comes to the practical, then the things are a little bit different. For example, if I tell you I was working on a project, there was completely whole concept of RF. But for example, if I don't connect or properly ground a component, it won't work. It won't give me the result that I required. So it took me like about like 6 to 8 months to realize that there is a specialized kind of a material that is used for PCB manufacturing and fabrication. Then there is a special kind of transistor that is used to give that kind of a output. So that started to give me an interest how these things work, and like give me most enthusiasm when that practically the project worked out.
Very nice, very nice. And what is the job scope? If we say job scope inside Pakistan, which companies are the main companies they are handling these kind of, and also abroad as well?
Dr. Sab, actually, initially I told you that when going back to 10 years back, there was only 1 to 2 companies that were associated with the forces and the international market. So there the scope was limited. As the 10 years go past by, like around about within Islamabad, there's like 10 to 11 companies that are working for the same RF radio microwave technology. And if I go like after 10 years, there are a lots of scope. Like my colleagues and my students somehow and my junior have joined the all the reputed organization that you see in your the company name logo on your company. Like Nvidia is a really nice
Yes.
processing making. People are working there. Then there is a product that we use in our phones, Apple. The most of our two of our colleague are working there. So there is a lot of scope. But being in Pakistan, there is no guidance. Like for example, for me, if I tell you my side, I don't have a career or nobody to guide me where to take this path and how the things would add up. Now after 10 years, I can like proudly say I can guide new students to where they can start, how they can get information, and after getting a practical experience, they can join the companies, and where are the companies and which area would be suitable for them.
Very nice, very nice. And you have grown up as the design engineer to manager. So, what leadership qualities matter for the high tech team, or some that are
Dr.
more important? Yes.
Okay. Dr. Sab, actually, I have learned a lot from my seniors, and my company has supported me a lot in like teaching me how to get to this position. So initially, the leadership quality that I would say is if you're like working somewhere, you should have if you it's a two-way process. If you're getting something, you have to give it back. So all the new comers or new students or engineer that are working for you, you have to help them. You have to provide them all the knowledge they have. Maybe you get to know something from them, or maybe they will teach you something. That's a two-way process, first of all. Secondly, like me, I was looking for somebody to help me and guide me. So in the same way, a leader has to guide the team. So if there's somebody stuck and need a motivation from me, I'll guide him and give him a path, so that the same way like I was working on the project, if somebody would guide me like for 1 month, I would have done the project of 6 months just in 1 month. So you have to guide the team. Secondly, you have to take the steps from them. Like if somebody is asking me to say, I need a practical lab or I need a special tool so that I can work and knowledge, you have to provide them. This is how the practicality works, and you have to teach them the take them through the tours, so that you can tell them this is a practical, and motivate them that this is a system that we will design and this is how it works. So the more you give them opportunity, the more they will be linked to you.
Very good, very nice. And another Hassan bhai question, that many engineers struggle to shift from technical roles to management. So,
Okay.
what are the steps if you can guide as a decision maker to evolve into a decision maker?
Dr. Sab, actually, the being a manager and working practically are two different things that I have encountered. When I used to work practically in labs and designing on the PC, the role was a bit different, because I have to be working solely on the one project as well, or like one problem at a time. As I came to the manager, I have to take a bird's eye view. Like I'm managing somebody, giving them the task as well, and on the other hand, I have to verify and telling them the things how to research and work. So being a manager, you have to do a 50-50 job. You have to manage the things as well, and you have to guide them technically how the things will work out.
Very nice, very nice. That's good. And bird's eye view is the key for the
Yes,
decision makers. And
because because being a
Yes.
manager you
Yeah.
have to you don't get involved in PC. Like when I was working being a test designer or whatever, I was like 24 hours. It took me like 18 hours, sometimes like 8 hours as well, to continuously work on that one problem. But being a manager, I have to be responsible for their counter and answer for their doings and tell them how to do this and guiding them. So it's like your mind have to be work like multitasking for doing the designing and telling them as well. And mostly it involves like testing and practicing help. You don't have to like the design. You have the team to work for that one. You divide that six whole project into six different chunks, and you have to collect them and show the how this works. You cannot like do all the six chunks yourself.
Very nice, very nice. This is two phases. In first phase, definitely you have to go. There's no shortcut. You have to go the
Exactly.
process, a detailed process of technicalities, and then to shift in that. Yes, that's nice. Yeah. And what advice you want to share with young engineers who want to work in defense and communications in Pakistan?
Okay. For the young engineers, I would like to tell them like to study as much as can, but study is one thing, but you have to put that study into practical work as well. For example, like I told you, that the book thing is one thing that you have to learn. You know, you have to accept the process. Sometimes the thing written in the book, you have to prove that when you come to lab, there is a totally different thing you see, and there's a lot more learning. Like, I have been seeing, like I'm working like for 10 years, but 10 years every day when I come to lab, I have a different kind of issue, different kind of learning that happens. Recently last week we received a vector analyzer. That's a kind of equipment that we use to measure the measurements of an equipment. So there's a system I was working on, but the thing I've studied was totally different when I was measuring the system. So I got the manual and read that the limitations can be exceeded if you go into the software and read it out. So that's how you have to continuously work and use the practical knowledge as well. Being a student, there's one more thing. Students usually don't get involved in practical works, so I would advise them to join lots of. There's a group called IEEE that basically help the students to get into the practical knowledge. There's a lots of seminars going on there. They can learn and meet new people. Lots of teachers and lots of young professionals that are coming, and they get lots of exposure from the companies and lots of other that like you have searched me out. But when you come to seminar, you get face to face with the people and learn how the things are working, what the practical work. Secondly, I would like to advise them that they should after they should don't spend time in internship, because internship is such a waste of time. Because the time the internship ended, you just like studying somewhere, or they'll give you a research paper or something. So I would advise they should go into the practical work and join the company and learn things and new software. Like for me, there like in RF engineering there is a three-step process. First, we got a requirement from the company, or we have already isolated a problem. Then we picturize it, go for a paperwork diagram. The paperwork tell us which components are which are needed. Because being a engineer, there's like what the field I'm going through is like R&D field. So in R&D, there's like a most of the budget is going to the component. So we have to be very selective and very precise about how the component selected. So in the first process, we have to go through the block diagram and paper diagram that we have to be sure like 100% this is the design. After that, we have before sending the practical ideas for the manufacturing or something, we have to do the simulation of the projects. Like simulation in the sense, if I'm designing a PCB for the transmission, but I don't know how it will work. But there are software called ADS that I used to work. There's a different option that I can set, which in which how practically it will work. Like close to everything is not 100%, but it will give me a close to 80% idea how the things will work. After that, there is another tool I told you, like that I have an idea of making a transmitter. Then the transmitter is verified through another software called HFSS, where I know how my practical design will work. When I'm like 100% sure the thing is working as I have designed, then I'll send the file to manufacturer and they'll get to. But after getting the files or all the practical work, the main thing that already told you, the lab work is another kind of active tool that we have to work on. So there the design that I'm working on, is the really like painful thing, because the if I am desiring the thing to work smoothly, that I put a signal at one end and I'll get the signal at another end the way it works. No, that's not a problem. I have lots of issue like parasitic signals that will allow inserted. I have to work how the filter works. Sometimes the kind of filtration I need is not practically the way I used to work. So I have to sharpen this project. Then the transmitter, the PCB that I'm working on for the transistor, I have designed. Sometimes the results are not as required. So what I do is I work through different components and sets. It's like impedance matching. We call it impedance matching. Like how what I input and what I require. So both end we have to work on that. So the more they will work on hand, the more they will know. So I'll
Very good.
advise the students to get to know how the tools and the simulation works out and what tools are required for that.
Very good, and it's very it's something you highlighted very important point. Internship. People's usually universities also have the compulsion for the students to have 2 or 3 internships during their engineering. And
Exactly.
what do you think this very important from shifting from internships to new softwares, and how universities can shift their role from internship to something like that, and hands-on, you told the hands-on practice, and what's the offering industries in this field are doing for the students, so that during the bachelor degree they can learn and something. Is there any facilities available, and what
Uh,
skills? Yeah, please.
Dr. Actually, there are very few universities that allow the students to this kind of activity. Like most of the, as you have told, that most of the internships are not worthy enough that they could learn. Like it's a kind of a requirement that they have to fulfill. So somehow they will do it. Like it might not link to their subject or might not link to their degree, but they have to do it for just for the score. For that, the students, the university can sign an MOU with the companies like outside companies, and they allow their student to work there. Like for example, if a university asks that we have a project that came from a company, and there will be an internship for the students who will work for that. In this way, the university can collaborate with the companies and have get their MOU signed that whenever the project and whenever the chunk of that whole system, the student can design and learn from that. One thing is that. Another thing is that the companies can there is a hassle of another project that is called hiring project. Because I am an engineer, I'll hire somebody that have 100% knowledge so he can help me, or like a company would like to. Why should we waste like 2 to 3 months teaching some student, and after that, what is the job requirement, or they have a job security for them.
Yes.
So I would request like the companies, they can go to the campuses and see how which students are working, what are their capability, and ask them to work from them after hours, or like they have lots of time. They can work with them in some kind of project, so they can recruit directly from the university. They don't have to like waste their time going here and there.
Very nice, very nice. And you mentioned 2 softwares like ADS and HFSS. Is there any other skills or tools or platforms they have to master during their engineering, please?
Actually, there's an RF is not a single fit, as I told you. Like there is a field that's working on a receiver. This is a totally different. Then there is a field that is working on transmitter. That is another field. Then there is a field that is solely working on how the system should work easily and don't emit the unwanted side. That's called EMI, EMC. And then there's another field. Like there's a whole lot of field that you can work on. So you have to list down those things which you find suitable and you find more exposure to. So softwares that I use, that we use, like mostly here in Pakistan they use is ADS. That's for like PCB manufacturing and simulation. Then there is another software. It's in ADS as well, and some software sell it online as well. That's called system SU. That tells how the system will work. If I have designed a PCB and it will join to another PCB, how it will work my way, you can see it practically in the system. Then there is another software, HFSS, that usually designed for the antenna system. Whenever I have made a transmitter system with 2 chunks, now I have to combine a third system, how to radiate that transmitter. This is another field that practically works on antennas. Like we have seen the antenna are working our phones as well. So it's a whole lot of different field. Then there is a whole team that is for testing as well. Testing is another a great example. I told you, like, if I made a project but I don't know how it work or how it will handle. So there's a lab testing, the test engineer we call it. There the students or whoever is working should know how to use the equipment, like vector analyzer, spectrum analyzer, power management tool, all the tools that are working on. When then another last field that is most difficult, I would say, is compliance certificate. Like, for example, you're a customer and you ask me to design a system that will work from 0 degree centigrade as well as plus 70 degree. It's a whole scale of knowledge.
Yeah.
But designing a system, I'll design a system uh, for your requirement, but I have to qualify that system. So your requirement is working in both end, like extreme hot and extreme cold. So you have to know what are the standards of all the world they are following. Like, there's a military standard. Sometimes there is some companies and some customer follow European standards. Some are following like American standards. So you have to know how this is another field. But living in Pakistan, I told you that there is not a hierarchy that has to be developed. You have to be like one whole army who knows everything. But I would suggest the students to pursue this the field one at a time.
Very nice. That's nice. That's nice. And because due to the rapid technology changes in this field, you recommend any specific books, websites, or mentors? Do you think in this field?
Exactly. For the I guess lots of new generation are going to internet. Like, the most common thing is like YouTube, where there's the software AD is developed by the LabVIEW and all the system. They have a separate channel where they show each and every component how their software works. So that is one thing they can follow. Then I told you there's a international community called IEEE. There the student can join with a very minimal fees. So there they post their generals, their questions, and they have a community, whole lot community. They're telling the how the new practical world is changing, what is new in the design. Like, if I told you, I was working on a system. If you remember, we used to have a television that had a large fluorescent screen and used to turn on,
Yeah.
like, it'll take like 5 to 10 minutes to turn on. But now they have changed into LCDs, and we are using those same transparent tiny micro, and it'll be exactly the size of my finger. So that's how rapidly it is. If you get in touch with the thing, then there is another tool where you search me like LinkedIn, and there's a whole lot of community. I have learned that if you stayed in one place, you cannot learn from them. If you like explore, go to another place, you can learn a lot, because LinkedIn is a big community. There are lots of groups, and there are lots of pages where you can post your question. Like, I was having a issue uh, in my one of my system. I posted it online. I was expecting nobody was going to reply. Then after a day, I there were like around about like 10 messages, and the people were commenting right below, and everybody was telling their experiences and guiding me. So that day I realized that how the community is so positive, and how they pursue the problem.
Very nice. That's nice. Very good. And Hassan bhai, what are the most common mistakes you see and junior engineers are making in RF testing or circuit validation?
uh, uh, the juniors, first of all, they need a little guidance. I would like suggest the seniors or the mentors to teach them how they work. Like, for example, if you ask me how I work with them, it's like I constantly keep on check how what did they like struggling from. For example, one of my teammate was trying to figure out how the distance of two systems should be maintained. So I was like, what's taking him so long? He like told me that this is the problem that I'm facing. So I told him that you go through the same website I told you and search for the problem. And literally he was like done with the problem. So I told him, like, you have to be connected with the students, because they are the backbone of you. Like, right now I'm in my management position, I have to rely on my team to work for them. If I'm not guiding them, so everybody is like going to work for themselves. So first of all, secondly, you have to get them involved in some kind of activity all the time. Like, if there is a kind of a session going on in most of the university, at my time there was a very minimum thing that you have to arrange a class and bring something out of the university to teach them. But now it's I have seen lots of universities and lots of companies that provide you services, and you can ask them and make a little syllabus and give them in Dutch every day. Like in my office, I used to do is arrange us a person from this from some field, or even we have like lots of experienced engineer that we arrange a class and for the topic, so new students can learn from them. So these are the two things I think they can guide and new students. But there's lots of other thing if I go somewhere from my country, like in European places, they arrange special projects and collaboration for the students to work on them. This is how, like, you have to keep them interested. Otherwise it's a kind of a dry field, I tell you, testing. So people might get lost in that as well.
Yeah, yeah, very nice. Well, thank you very much, Hassan Bhai, for this detailed discussion and your thought-provoking answers and your experience you have generously shared, and your wisdom. So really thanks. And final notes from your side before ending this session, please.
uh, just a second. I have a little something written for me. I wrote down
Yeah, yeah,
some
sure, sure.
thing if I would like to share it with you guys.
That's nice. Yeah, that's nice.
If you ask me, like, what would be the ending words, I would like the new students and practical to master on the fundamentals first as well. Like RF is I told you RF is a wide field. So stepwise, if you start from the basics of the basics of that knowledge, like basics, like what are the transmission lines, what are the impedance matching, Smith's chart, and how the matching network works. This is the practical start from where you can know how the RF works, because it's not like a normal digital electronics. These are the concepts that you have to work with. And secondly, when you have done with all the building blocks, then go to the simulation tools, where you can practically see how these tools, the blocks that you're gonna combine, how they're gonna work. Then practically when the systems comes out, I have seen most of the students and young engineers, they just design the system and let it go, because the main learning after that is where you have to go to the lab and see how the thing's gonna work. So like testing is another way you can learn a lot from the practical experience. And mostly what we are doing in the lab might not work in the field as well, because we are making just a chunk of that cake, and the whole cake you have to go somewhere and taste it. So like you have to work on that as well. And finally every day is a challenge in RF field. So I would like advise the students and all the young engineers to learn from that challenges, not to like seek if it's not working, because that's the when the whole system gonna work. That's where you feel achieved, and you'll practically will you have done something.
Very nice, Hassan Bhai. Really thanks for this ending, especially ending notes and your struggle to convey something to the audience and your
Mhm.
motivation. Really, until next time, stay to the audience, stay curious, stay sharp, and may your signals always be strong and clear. Thank you. Take care, Hassan Bhai.
Thank you, Dr. Saab, for having me here. I was like really happy to see how you have searched and working so much for the new generation and your audience to bring out somebody from this special field and bring them to your live stream and tell them how the things are going to work and how they can pursue. I really appreciate that.
Thank you. Thank you very much,
And
Hassan Bhai.
last of all, if Dr. Saab, if any of your audience want to connect me, you can share my profile or my message, so I can tell them and guide them how they can go through all this field if they
Yeah,
like.
very nice, very nice. And let me, before ending this session, let me share your screen. So anyone who want to connect Hassan Bhai, so they can connect Hassan Bhai with his linked profile. So here is the linked profile, and you can see Hassan Bhai here, Hassan Mushtaq, and then you have the you can search, and I think so there is no issue for that. And Hassan Bhai will be there, and especially for the universities, because Hassan
Yes.
Bhai pointed out a very important issue where students are doing the internships here in Pakistan, and universities are compelling students to do the internship, and this is the main requirement: 1 to 3 internships. I think I will say in this specific field, the university's higher administration should contact Hassan Bhai and to have some MOUs to manage some
Exactly.
MOUs between industry and university, and this will be the initiative and step by step to other universities and other fields as well. So Hassan Bhai will be there to serve you. Thank you very much, Hassan Bhai, again for your motivation, for your guidance, and everything from your side. Thank you very much.
Thank you, Doctor. Thank you.
Thank you.
Yes.
Bye bye.